Welcome to part 2 of polynomials, in which we'll be learning about the relationship between the zeros and the coefficients of the polynomial. Now, before that, let's quickly recap what we learned in part 1 video. So, what are polynomials? Polynomials are nothing but a combination of variable and coefficients. If I were to take an example, let's take an example of polynomial px is equal to 2x square plus 3x plus 5. This is a polynomial in which the x is the variable and this 2, 3 are the coefficients. Now, types and degrees. So the types of the polynomials are dependent on the degree of the polynomial. And what is the degree of a polynomial? Degree is the highest value of the variable in a polynomial is called the degree of that polynomial. So if the degree is 0, then it is nothing but a constant. And examples of constant can be 2, 3, 5. If the degree is 1, then the polynomial would be a linear polynomial. Example 3x plus 2. If the degree is 2, then we call it a quadratic polynomial. The example is this, the above one, 2x squared plus 3x plus 5. If the highest power of the variable is 3, then we call it a cubic polynomial. The example can be x cubed minus x. Now, what are the zeros of the polynomial? So for example, let's take any number, any real number as k. So k can be called a zero of a polynomial when pk is 0. So then we can say that k is the zero of the polynomial px. And now what is the maximum number of zeros that a polynomial can have? That depends on the degree of the polynomial. Say if we have a cubic polynomial, then the max it can have is 3 zeros. And the same goes for quadratic. It can have at max 2 zeros. Linear, it can have 1 zero. Now, what is the geometric meaning of zeros of a polynomial? So in our previous video, we learned about the shapes that each polynomial creates. A linear polynomial would be a straight line. A quadratic polynomial would create a parabola. And the cubic polynomial would create a wave. Now, these points where the graph of the polynomial interacts with the x-axis, these points would be the zeros of the polynomial. And this shows the zeros of the polynomial in a graphical term. Okay, so if you want to learn more in depth about this, do go and watch the part 1 video of polynomials. Now, moving on to the topics of this video. The first topic that we have is the relationship between the zeros and coefficients of a polynomial. In the previous example, I told you 2x squared plus 3x plus 5. X is the variable and 2 is the coefficient. So now what we're looking at is the coefficients and the zeros, the relationship between them. So now let's see. We have already seen that zero of polynomial is minus b upon a. Obviously, if we look at ax plus b and we equate it to 0, then x would be turned out to minus b upon a. This is the 0 and this is what the value of it would be. Now let's look at a quadratic polynomial. This would be a little different because a linear, as we know, linear polynomial has only 1 0, but a quadratic polynomial has 2 zeros. So let's look how they interact with the coefficients of the polynomial. Now let's take an example of this, 2x squared minus 8x plus 6. Now in the previous class 9, we've already learned how to split the middle term. So in this, we would be splitting minus 8x. So the sum of the two splitting terms would be 8x minus 8x, and the product would be 12x squared. So if we split this into 2x squared minus 6x minus 2x plus 6, then this would give us 2 multiplied by x minus 1 multiplied by x minus 3. So now if we see the two zeros that we get for the previous quadratic equation would be x is equal to 1 and x is equal to 3. Now we've gotten two zeros, 1 and 3. Now, if we look at the sum of this would be 1 plus 3 would be 4. Like you see here, we get 4. Now, this 4 can also be represented as minus whole minus upon 2. So now, if we look at this polynomial, minus 8 is the coefficient of x and 2 is the coefficient of x squared. So we can also write it as coefficient of x upon coefficient of x squared, and there's a minus sign here. So the sum of the zeros of a quadratic polynomial would be this. That is negative of coefficient of the variable x upon the coefficient of variable x square. Now, if we look at the product of the zeros, that is 1 multiplied by 3, it would give us 3, right? And it would also be 6 upon 2. Now, what is 6? 6 is nothing but the constant term of the polynomial upon 2. 2 is again the coefficient of x square. So now, if we were to write this in a general term, this is how it would be. In general, if see this, these symbols are called alpha and beta. This is alpha and this is called beta. This is the general notation that we use for zeros of a polynomial. So if alpha and beta are the zeros of a quadratic polynomial, ax square plus bx plus c, then x minus alpha and x minus beta would be the factors of px. Obviously, whenever we write a polynomial, we always write it as minus beta in the terms of factors. So that is what we have done. If we open this bracket, that would bring us here. That is k. Instead of a, they have written k. It means the same thing. So k x square minus alpha beta x plus alpha beta, right? And if we open it, this is the expanded form of the polynomial that we get, right? And now look at this. In this, if I were to write, the coefficient of x is minus k upon alpha plus beta. Now, if I divide it by just the coefficient of x square and I give a minus sign to the whole upper, the negative cuts, the k cuts, what am I left with? I'm left with the sum of zeros. Now, right here, if we look at the constant term, that is k alpha beta, and I divide it with the coefficient k of x square, k gets cancelled out and we left with alpha beta. That is a product. So if we look here, the sum, this alpha beta is the sum of the product. Sorry, this is the sum of the zeros, which is given by minus b upon a, right? And what is b? B is coefficient of x and a is coefficient of x square. This is exactly what we proved in the previous slide. Right, now look at the product alpha beta. Alpha multiplied by beta. C is nothing but constant term and a is nothing but coefficient of x square. So always remember this. A lot of questions would be asked on this. Calculate, you will be given a polynomial and said calculate the sum of the zeros or the product of the zeros. So rather than solving the whole polynomial, you can just calculate it with this formula, minus b upon a, and product calculated by c upon a. Now let's move on for a cubic polynomial. Now in cubic polynomial, it's a little different because in this we can have maximum 3 zeros, right? So let's take this example, 2x cubed minus 5x squared minus 14x plus 8. In this, the zeros of the above polynomial would come out to be 4, minus 2, and 1 by 2. Now, if we were to do the sum of zeros, right? 4 plus minus 2 plus half would give us 5 upon 2, which would in turn can be written as minus 5 upon 2, which is also minus coefficient of x square and coefficient of x cube. Now, in the quadratic polynomial example, the above coefficient was of x and the denominator coefficient was x square, right? So whichever is the degree of the polynomial would come in the denominator. Here it is 3, so cube, x cube, the coefficient of x cube comes in the denominator, and in the quadratic one, 2 was the degree, so x square, coefficient of x square was in the denominator, right? Now, if we look at product of zeros, 4 multiplied by minus 2 multiplied by 1 by 2 gives us minus 8 by 2, which we can also write as negative of constant term upon coefficient of x cube. Here also, in the quadratic one, in the denominator, we had the coefficient of x square, degree 2, so denominator x square. Here, degree 3, so denominator x cube. Remember this. Now, in a cubic polynomial, we have one more concept that is known as the sum of products of 0 taken 2 at a time, right? So if we were to talk about sum, then it would be x plus beta, sorry, alpha plus beta plus gamma, right? And sorry, I'm introducing a new term. That's this is called gamma. It is GAMMA, and it is written as this, right? So consider these three are the zeros of a polynomial. So this would be the sum, this would be their product. Now if we were to take them 2 at a time, say alpha beta plus beta gamma plus alpha gamma, then how would we calculate this value? This is exactly what we do here. We take 4 multiplied by minus 2 multiplied by 1 upon 2, 1 upon 2 multiplied by 4, and then we add all of them. So this gives us minus 8 minus 1 plus 2, which gives us minus 7, which can also be written as minus 14 upon 2. Now what is minus 14? If you look in the polynomial, minus 14 is nothing but the coefficient of x, right, upon the coefficient of x cube. So the degree, if the degree is 3, then in the denominator the coefficient of x cube would come, right? So just to this was an example, let's generalize this, right? So in general, it can be proved if alpha beta gamma, see this is gamma that I told you about, are zeros of a cubic polynomial, ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma would be minus b upon a. What is b? Coefficient of x square. A, the coefficient of the degree of the polynomial. Now if we look at the sum of product taken 2 at a time, alpha beta plus beta gamma plus gamma alpha, c upon a. What is c? C is nothing but the coefficient of x. And what is a? A is nothing, coefficient of the degree of the polynomial, that is x cube. Now if we look at the product, alpha beta gamma minus d upon a, and what is d? Constant, and a is the coefficient of the degree of the polynomial. Now just for comparison, I will write here about the quadratic so that you can compare. So for quadratic, alpha plus beta was minus b upon a, and the product was c upon a. Remember, see, in the denominator, it will always be a, right? And for the product, it would be the constant term. And for the product, for the sum, it would be the second highest value. Say x cube, it has a, so the second highest is square. It would be b. In that, second highest was ax square plus bx plus c. So second highest was x raised to the power 1. So therefore b. So this is what we call about the zeros, the relationship between the zeros and variables of the polynomials. Now these are some questions that you can try. These are easy questions. It would use the concept that we've just learned. So try these, and thank you.